Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers. Students were given measurements to 1 decimal place, and a single slip about rounding cost entire method marks. If I show you how to write 2 tiny lines of working, you will secure those marks, even if your final multiplication is a bit messy.
Promise and roadmap. In the next 12 minutes, you'll understand exactly what upper and lower bounds mean, why the examiner asks for them, how to present them to get marks, and one 20-second check you can use in every question. After this episode, you'll be able to handle every standard bounds question in an exam without panic.
The concept. Start simply. If a measurement is 2.4 centimeters and it's written to 1 decimal place, the true value could be a bit smaller or a bit larger. The standard rule is the lower bound is half a unit of the last decimal place below the value, and the upper bound is half a unit above. So 2.4 to 1 decimal place means 2.35 less than or equal to x less than 2.45. That inequality is important. The lower value is inclusive and the upper value is exclusive.
Why that inequality? Imagine numbers that round to 2.4 when you round to 1 decimal place. Anything from 2.35 up to but not including 2.45 will round to 2.4. Writing 2.35 less than or equal to x less than 2.45 tells the examiner exactly what you mean. No ambiguity.
Now, an example that causes trouble. A rectangle with length 2.3 centimeters to 1 dp and width 4.1 centimeters to 1 dp. First, find the bounds for each measurement. Length is 2.25 less than or equal to L less than 2.35. Width is 4.05 less than or equal to W less than 4.15. Then area A is equal to L times W. To find possible areas, use the smallest possible length times smallest possible width for the lower area and the largest possible length times largest possible width for the upper area. This gives 2.25 times 4.05 less than or equal to A less than 2.35 times 4.15.
Calculate those products carefully. Don't round intermediate values early. 2.25 times 4.05 equals 9.1125, and 2.35 times 4.15 equals 9.7525. So the area satisfies 9.1125 less than or equal to A less than or equal to 9.7525 centimeters squared. If the question asks for bounds to 3 decimal places, you would give 9.113 less than or equal to A less than or equal to 9.753 centimeters squared. But you only round at the final step when the question asks you to. Keep precision during the working, so you can't be accused of sloppy arithmetic.
Worked example and mark breakdown. Here's a common exam-style question. A rectangle has sides 2.3 centimeters and 4.1 centimeters, each given to 1 decimal place. Find the upper and lower bounds for the area. How do examiners award the marks? Typically, this is a 3-mark question. M1 for setting up the correct bounds for L and W, M1 for applying the correct method to find bounds for A, and A1 for giving the final numeric bounds correctly. So even if your final arithmetic slips, the 2 method marks are available if your setup is clear.
What to write in the exam to capture those method marks? First line, write the measurement bounds explicitly. For example, 2.25 is less than or equal to L is less than 2.35. 4.05 is less than or equal to W is less than 4.15. Second line, write A is equal to L times W, so 2.25 times 4.05 is less than or equal to A is less than 2.35 times 4.15.
Third line, calculate the product and state the bounds with units. Those 3 lines show you understand the method, and examiners love this clarity. Write it down, don't just think it. Common mistakes to avoid. Mixing up rounding rules with bounds. Rounding 2.3 to 2.30 and then adding or subtracting 0.5 is wrong. Or students round each intermediate product to 1 decimal place and lose precision, which can make the final bounds incorrect. Also, failing to show the inequality form loses method marks even if the numbers look right. Examiners want to see the logical chain. Exam technique. Present your answer the examiner-friendly way. Label lower bound equals and upper bound equals, or use the inequality, lower less than or equal to quantity less than upper. Always include units on the final line. If the question asks for bounds to a specific number of decimal places, do your final rounding at that step and state it. If you are running out of time, at least write the bounds for the measurements and the expression for the area. That's often enough for the first M mark. Marks are there for the taking.
Quick win. A 20-second checklist you can use every time. 1. Identify the precision, DP or SF. 2. Write the lower and upper bounds for each measurement using plus or minus half a unit of the last place. 3. Substitute into the formula exactly as inequalities. 4. Multiply using full precision, then round only where the question asks. 5. Put the answer with inequality signs and units. Say this one line if unsure. 2.25 less than or equal to L less than or equal to 2.35. 4.05 less than or equal to W less than or equal to 4.15. So 9.1125 less than or equal to A less than or equal to 9.7525 centimeters squared. That single sentence protects marks. The 20-second mental midpoint test. Take the average of your upper and lower bounds for the final quantity and see if plugging the average values back into the formula gives something near that midpoint. If it is wildly different, you probably mixed up a bound. This only takes a few seconds and catches most mistakes.
Practice challenge. Try these now. Prompt 1, 5 minutes. A cylinder has height 12.1 centimeters and radius 3.2 centimeters, each to 1 decimal place. Find bounds for the volume. What 3 lines would you write to secure method marks? Hint, bounds for R and H, then V equals pi R squared H, inequality. Prompt 2, 4 minutes. A triangle has base 5.0 centimeters to 2 significant figures, and height 3.45 centimeters to 2 decimal places. Find bounds for the area. Suggested timing, 3 to 5 minutes each in a practice session. Even if you don't finish, write the bounds for the measurements and the formula. That's how you earn M marks.
Quick technical note for significant figures. When a value is given as 5.0 to 2 significant figures, the bounds are 4.95 less than or equal to B less than or equal to 5.05. The same half-unit rule applies, but you count the place value based on significant figures, not decimal places. If that sounds fiddly, add the one-line note in your working to show you understand the principle.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find a free 1-page bounds cheat sheet and full worked solutions at jcacademyonline.co.uk. Stay curious. I'm Dr. James Carter. Trust the process and nail that exam.